and welcome to today's Industry Week webinar, Unlocking Human Potential in Frontline Operations with Composability and AI, sponsored by Tulip. My name is Dennis Semeka, Senior Technology Industry Week. I would now like to welcome our speakers. Madilynn Castillo, Head of Marketing at Tulip Interfaces, champions a human-centric approach to operational technology. Tulip, a spin-out of the MIT Media Lab, democratizes operational tech by combining user-centric no-code capabilities with powerful native technologies like computer vision, AI, and edge connectivity. Mason Glidden, Chief Product and Engineering Officer at Tulip, is responsible for Tulip's product engineering and support teams. Since 2015, Mason has had a hand in growing Tulip from a 5-person startup to the 300-plus person company it is today. With that, welcome to you both, and the floor is yours.
Great. So today's agenda, we're going to go over why digital transformation is important to do generally, and also why now is the time to be thinking about it. We're going to talk through composability, both from a theoretical and practical perspective, and how it's key to unlocking the potential of your workforce and people. And finally, we're going to talk about how these things come together and our key considerations when thinking about applying advanced technology like generative AI. So why digital transformation? Why now? Not to, preach about what's going on in the industry to people who are living in it and very aware, but, manufacturing has changed rapidly over the last 20 years, let alone the last 5 years. That's changes in supply chain, that's advancements in technology. There's a lot more data, almost to the point that it can be difficult to use, but it's also critical for business to understand. And there's incredible changes happening in workforce, both the composition, trends, competition with other industries and roles that maybe didn't exist 5 years ago. And all of these things are happening really rapidly, almost at a speed unheard of before, but that we expect to continue to see over time. This is the new normal, so to speak. And when we think about all of these challenges, ultimately, technology is just a tool to help the companies that are purchasing it adapt to and solve their problems. They're just tools. So the tools themselves and the things that they're designed for are not necessarily in line with the challenges we're seeing in the market or the needs of the people doing the work. And when you look at the biggest opportunity quantitatively for operations, that's mostly around where people are doing work and how to engage and better manage the work that's being done. And that's the place that has been less of a focus when it comes to manufacturing tech, both in usability and application of the technology, and also the way that technology is used to solve and integrate with those problems.
Now, this isn't just an approach problem. It's also a market support problem. Technology today monolithic solutions are fundamentally underserving frontline operations. There are two specific areas where they really fall short. First up, agility and extensibility. Your operations changing quickly, monolithic software can't. And you have a fundamental mismatch between the cadence at which your operations have to evolve and the cadence at which your software and technology has to evolve. Secondly, it's not human-centric. A lot of monolithic solutions bend your process and your people to the software, not adapt the software to the people. It's just a sort of fundamentally wrong approach that continues to cause problems.
So principally, if you back out and kind of merge these two ideas together, the approach to problem solving and the way the tech is designed and the challenges that the industry is facing, that combination is needed to really make operations more resilient. You need better agility to respond to sourcing challenges, to workforce challenges, to retiring experts. And all of those things are, critical problems to solve and continue to be able to adapt to over the coming months and basically today. So that's the real answer to the why now. But as we kind of look forward to the rest of this discussion, we want to frame it into the real tangible problems and areas of focus. So thinking about utilization, thinking about that last mile of challenges where you can really get value that there's not a solution to today, and also starting to think about understanding what's going on and getting proactive with things you can start to do in the future to kind of get out of this responsiveness to things that are coming your way and better navigate and be decisive about things that you could do next. And all of that starts with a focus on the pain points and then selecting the technology and tool that best suits that. And with that, I want to introduce this concept of composability as the way to think about how you select and build those tools. So composability, it's in the title of this webinar. It's a big buzzword right now, but it's not a new concept. It's a common IT concept when you're thinking about software, purchasing, and technology. And when we use composability, we're really talking about it in two senses: that traditional sense of the word, composable architecture, that modular approach or software design approach that allows for integration through APIs with other systems and has set modules that you can use and kind of plug in and out that have their own defined characteristics. This is a modern architecture. And really, when we think about composability today and composability in the future, really does need to be a cloud native or cloud supported architecture. The second piece that ties back to that ability to own your solutions and pull in the technology that you need when it's the right type of technology for the problem you're facing is composability as a solution design approach. And when we think about what Tulip is and Tulip's approach to this, or our ethos, when we think about our platform, it's to enable this type of composability. So create the composable architecture in the platform that enables a composable approach when it comes to solution design. And how we see that done today is often with no code and an iterative rollout with apps and widgets, which Mason will talk about in a bit. But it's more the conceptual thing that we're working towards and kind of thinking about when we make adjustments to the product, and that our end users are thinking about when they're facing a new thing that they need to solve in their operations.
Building off of that and both of those definitions of composability, software for frontline operations right now is fundamentally changing. On the composable architecture side, the cloud has driven an enormous architectural change in how software is constructed and built over the last 15 years that has huge implications, not only for the scalability of these systems, but also for the extensibility of these systems. When you build in this composable way, it forces a certain set of openness and APIs into the product that end up benefiting the end user as well. Composability within the product is also becoming really important. Those problems we talked about before, where frontline operations are being fundamentally underserved by the technology, composability is part of that answer, right? Letting people build and compose their own approaches that can then replace these old monolithic systems. On top of that, you're also seeing two sort of buckets of capabilities that really have started to emerge. First up, connected. Frontline operations it's a physical thing. There's no escaping it, right? It's not an app that can just live on your phone. There's machines, there's sensors, there's smart tools, there's other systems you have to integrate with. It's connected into this web of other devices and systems, and you have to design for that from the ground up. And lastly, cognitive. Obviously, AI is a rapidly changing field. There have been some pretty cool developments here over the last 2 years that are just starting to make their way into production use cases and look like they're going to have pretty profound implications for how frontline operations runs. To talk about how Tulip is approaching all of this and the changing landscape, we're building a no-code, connected application platform specifically for the frontline operations workforce, building something that is tailored to those needs in terms of that connectivity, in terms of that modularity, in terms of that ability to change. To continue on here and talk through a little bit more detail about what all of that means, to break it down. So we start with a no-code app editor. You can go and add logic to your operations without having to write code. You don't need to be a software engineer to take advantage of some of the way that a software engineer might think. Tailor custom-built applications to your business process, not the other way around. As we talked about, this isn't possible without integration to the real world. You have to connect to these physical devices and systems that are all around the shop floor. There's no getting away from it. We have a pair of edge products that seamlessly integrate in with Tulip, and you can also extend beyond that to integrate whatever device you might need to support. Coming out of the other side of that, we have real-time analytics. Data is critically important today. Data to help make day-to-day decisions on the shop floor, data to decide longer term your strategy or understand the ROI of your line. We have a real-time analytics engine that's built on top of the product that pulls data from both those applications and those devices in order to give you a holistic picture of everything that's going on in your shop floor. And finally, this all connects with an ecosystem of content, both developed by Tulip and developed by third parties. We'll talk a little bit more about that in a second here. Now, all of these together create a truly composable approach. Instead of this old monolithic hierarchical approach to software, it's very static software, you have a citizen developer-led composable architecture. This allows much more agility, much more flexibility, and overall just a much better approach to running your frontline operations. Now, this really empowers your engineers to create powerful solutions that they need. They know their problems, help them solve the things that they need to do, whether it's guiding an operator through a bit of work instructions or running an audit on the shop floor or anything else that might come up. Give them the power to do that themselves. Now, this applies to a center of excellence just as it does to those engineers. You want to mesh that bottom-up citizen developer approach. Hey, I have a problem. I want to build a tool to solve it, with best practices that can be applied org-wide, right? What's the best possible way to run a 5S audit? What is our brand template? What is our connection to our ERP? Build those in a COE and then merge that with, it's composable. You can merge, you can pull these different bits together and create one powerful solution. Take those center of excellence components, combine them with what the engineer on the front line is doing to give you a truly powerful solution that fits your operations. It's flexible. It does all the things you want it to. Now, this applies to our ecosystem just as well as it does to a center of excellence. This composable approach gives you good abstractions. And so you can pull in a piece of content from your center of excellence, or you can pull one in from a partner, or you can pull one in from Tulip's library. Because of the modular and composable approach that we're taking on for this, it's easy to abstract out and swap out one solution for the other to give you a really powerful and flexible approach to it. Now, overall, from a value and solution perspective, this is going to give you a much faster time to value. With a traditional monolithic approach, you're going to have a fairly waterfall-based process. You're going to start by definition. You're going to work through gathering all of your requirements. You're going to start to go, at some point, you're going to do testing, and eventually you're going to flip a switch. And we've heard so many tales of multi-year MES projects that fell apart on the finish line. People invested years and millions of dollars into this. There's nothing. And then they just hit something they couldn't cut back from, and it all just fell apart at the multiple of years in. Not only like loss of the time invested into it, but also enormous opportunity cost from not getting that solution out there. With a composable approach, you can start much smaller. You can start with a small little singular thing and then build from there. You don't have to go and build and then flip a switch on everything. Start with something small. Start with one audit. Start with one set of work instructions. Prove the value out from there, and then scale either horizontally to other use cases in the plant, or vertically going through all of the plants for that same use case. It gives you much more flexibility in your approach and allows you to receive value almost immediately instead of having to wait to that 2, 3, 4 year mark before you start to see a return. Let's talk about some examples of what this might look like on the shop floor. One big category here is the operator workflow. What is that end operator doing on a day-to-day basis? Initial solutions here might look like pick-to-light guidance, helping them pick out a specific part that they need at a certain a certain step in the assembly process. It might look like image capture, either for documentation and quality checks, or for automatic defect detection, right? Train a model on good and bad and automatically build that detection straight into the workflow for your operators. It might look like an ERP connection, right? Instead of having your operator have to go and say, okay, here's the instruction booklet, go open up this table, type in this, do that to update the ERP. Just have them scan a barcode and have a little app that goes and updates the ERP for you. So really helping your operator do their job more efficiently, give them better guidance, prevent and detect defects, things along those lines.
So just to add to what Mason's saying, I think we're zooming in and zooming out to like how we can iteratively add and pull in these different pieces through a composable approach. And it's not just the approach, but it's also the platform. So to add to Mason's point about modularity, rather than choosing from a set box of modules and trying to plug those in, if those modules don't serve you, there's an ecosystem of solutions and also just the core platform where you can develop when it comes to widgets and plugging those in, or swapping in and out the different pieces that match the needs of your operation today. So if, for example, you're using an ERP and you want to switch to a new ERP, composable platform allows you to update that integration. If you want to change the way that you're visualizing a specific gauge that you made in a widget, you can update that widget, and then you have the gauge that works better for you in there without having to rip things out or have this sprawl of a bunch of tiny solutions that you're trying to keep up with and have them not necessarily solve exactly what your process is. And while we have been talking about that from the solution and implementation perspective, we also mean that from the platform perspective. So technology is constantly evolving and changing. I think that the excitement around generative AI feels really rapid in like the last year and the last 6 months, even more. And when you think about a platform that's consistently improving and adapting to that technology, it means that while you may not have been thinking about using generative AI in your operations 2 years ago, you're able to today. And even if you're not ready to today, you have the basis to do it tomorrow when you're choosing a platform that lets you scale. And there's plenty of either evolution of this existing technology or maybe things we haven't started to talk about that could be available tomorrow and would be incorporated in the platform. So kind of thinking about future-proofing, not just from a resilience and adaptability perspective, but also from an adoption and advancement perspective. Really, how are you going to evolve and kind of keep up competitively as things change and there are new opportunities to leverage some of this technology to solve some of the problems that your teams are facing?
Let's talk about how all of this sort of connects and intersects with generative AI. Obviously, over the last year, there's been a huge explosion, or actually it's 2 years by now, a huge explosion in everybody thinking about generative AI, driven by a change in these fundamental models called LLMs or large language models. You've seen an enormous amount of venture capital money go into startups. You've seen existing companies try to rebrand to be generative AI companies. It's a huge buzz, and everybody's talking about it and thinking about it right now. But there's also a pitfall here. So going back to some of the things we've been talked about, or that approach of prioritizing the tech over thinking about your operational challenges, right? Like saying, I want to do generative AI, not thinking about, hey, I need to solve this problem.
And a famous example of that, just to bring it to, I think, something that we'd all recognize, is Tesla's initial approach to building out their factories and leading with automation. There's a lot you can learn from folks in operations. It's not something to discredit. You kind of want to go there and speak to the people doing the work and understand how to build that out. And here the pitfall was, if I see the people as a problem or people as a source of error, let's just remove the people and try to fully automate this process at an incredible cost and really gap here. So robots and automations and not having people is a really cool, futuristic, tech-driven idea, but it was divorced from the reality and needs of creating a great product and what Tesla needed. And so we'd apply the same kind of caution to how you're thinking about generative AI, but also how you're thinking about architecture, tools, your system approach generally, and really encourage everybody to focus on ROI or the work that needs to be done rather than the tools themselves. It's great to be set up to use the technology, and oftentimes applying the technology to the problem that can be solved multiple ways could help you solve it faster or better or more efficiently. And we'd encourage you to do that and set yourself up to be able to do that, but not, I have generative AI, like this is my hammer. Where can I find a nail and then start nailing screws? It's not something that'd be great for your operation.
So let's talk about where those real nails are, right? Where are the places to start thinking about now that are valuable, are useful? You know, don't worry. I know that we're also in a hype cycle right now. I know that a lot of the things that you hear are not going to happen, right? Like LLMs are not going to become artificial general intelligence in the next 2 years. We're rapidly actually moving through this hype cycle. I feel like every time we give this presentation, the arrow moves like another 10 pixels over to the right. But the goal here today is to talk about what are the real, like, what's the brass tacks? What are the things that are useful today, that are possible today, that help solve real problems today? Not, hey, we're just going to slap generative AI on everything, or hey, it's all going to replace all of our jobs in the next year. To start with, the first sort of foundational piece here is to get good data. Oftentimes, these new models that have come out in the past couple of years are really great on unstructured text-based data. People typing things in, doesn't matter the language, doesn't matter the format, just raw text. Now, this has been a source of data that's actually not been that useful historically, right? Imagine a defect report running on your line. Over the years, you're going to collect thousands and thousands and thousands of rows of data. That aggregate source of data isn't very useful. It's hard to do something with 100, 200 pages of text. Now, these models are fantastic at that, but you have to get that data first. So this type of data has become even more critically important, and places that are starting to collect it or have been collecting it now have an advantage in how they can start to apply it and get better value from it. This fits into a sort of overall composable approach, right? As you're going through this composable approach, you're going to start small, you're going to start to scale it, you're going to continue to evolve it. This gives you the perfect platform to then bring in future capabilities like generative AI, right? If you already have these applications deployed, but you weren't collecting that data, you can now go quickly add a step in there to get that data from your operator. A new model comes out that does blow our minds and does push even further what we can do. Great. It's just another module. You can just compose it in and put it in the places that it makes sense in your shop floor. To talk about what this looks like in practice, for example, let's say you have a quality app, right? That's showing off, it's doing your inspection at the end of your line. Great. Now you can go in and put a little step there to get a bit about what the defect was and use generative AI to automatically suggest a solution. Great. Now there's a new awesome model that can detect defects. Put a camera on that line and start taking pictures, right? You can build incremental value on this. You don't need to go and redesign your whole shop floor just because a new model came out or just because everybody's hyped about Gen AI right now. Now, when Tulip thinks about generative AI specifically, there are 3 main categories that we're thinking about, 3 different personas, if you will, of things where we think this is going to provide value, basically like the first nails to go after. First up, around the frontline operator, right? How do these tools help that operator do their job better, understand data, things like that? I was talking to a customer of Tulip recently that builds medical devices. Now, they've been collecting data like this for years, right? These root cause analyses of all these different defects. They're using Tulip's Frontline Copilot to build an inline quality check into the process where after the operator types in the defect, they go search the corpus of information that they've collected and automatically suggest a solution based on that data. Super valuable, lowering their time to fix these defects and essentially taking this captured tribal knowledge that they've had and putting it as a direct inline guidance. Super valuable for them, immediate, and they were able to deploy it super quickly as well because they had that data already. Persona 2 is around the citizen developer. Now, if I put my software engineering hat on, these new tools are really useful as a software engineer, right? I can go write code, and in my editor, it's like giving me suggestions and helping me write code faster. But it's not perfect. It's going to get things wrong. It's like maybe 80% right. It can do the boilerplate, the rough structure for me. I still need to be a software engineer to fix it and make it work. Now, this paired really well, actually, with no code tools, because now you don't have to be a software engineer to understand the output and do that last 20%. You just have to understand the no code tool, which is a way lower barrier of entry. Third is around data and analytics. Business intelligence is changing really rapidly right now. LLMs are fantastic at helping you make queries that you can then run against a normal structured database. So we see generative AI immediately helping people get to their data faster and be able to really quickly iterate as basically as quickly as they can type here. To quickly double click on what some of these examples look like. Right here we have the Tulip Frontline operator chat. This can go directly in an application and allow your operators to query their table of root cause analyses, or a bunch of manuals, right? Put a bunch of machine manuals in there, train a custom model on top of it using Tulip Frontline Copilot, and then have it query, hey, what do I do about an oil leak? What do I do for XYZ? Basically taking all of this massive source of text-based data and making it much, much more accessible. On the analytics side, we've now built in this chatbot right on top of your data. So you can go ahead and start asking questions of it and have it generate analyses for you. Now, these analyses are normal Tulip analytics. It's not doing anything special. It's not a proprietary thing. It's just the same analysis you're already used to in the Tulip product. You can go ahead and save this, add it to a dashboard, fire an alert on top of it, send it to somebody else. It's creating a reusable, composable artifact for you to then use later on. Lastly, and where a lot of you'll see things coming up in Frontline Copilot in the next couple months, is using it to build applications, really lowering that barrier of entry, taking advantage of all of the composable bits that either we have accessible in the library or that you've made in your COE, and combine that with an LLM to help you make applications even faster. Again, this is not going to be a 100% solution, but 80%. That's super valuable. Imagine taking a PDF of your work instructions and dropping it into Frontline Copilot and have it build the structure of that application out for you, so you don't have to do the repetitive work of copy pasting the rough format in. We're really excited to see where all of this goes, and we know all of these things are going to be incredibly valuable today.
I think that's a great point too, Mason, is that there's some amount of things that the team is totally capable of doing that are not necessarily valuable. Like doing the sketch of a work instruction app template isn't necessarily the best use of their team's time. So really getting them to focus on things that their unique knowledge helps them out with. Well, thank you for talking through the topic with me today, and for everyone who's joined. You can scan this QR code to get in touch with Tulip and see a demo, or go ahead and visit our website. We have a virtual tour of our experience center where you can see different demos and use cases and partner ecosystem use cases to learn more about how a solution that's more composable could potentially work out in your shop floor or your operational environment.
Okay, let's go ahead and begin our Q&A session. And with that, the first question. So this data helps to formulate bottom line. What are our costs? Where are the breakdowns?
So the way I'm understanding this question on formulate the bottom line is you understand the data that you have and the impact that having it would be, but what is the cost for setting up the solution and what the breakdowns might be. And I think that when you think about cost, that's actually where time to value as well as implementation and incremental implementation really shines with a more composable approach, because you can start seeing, impact on your bottom line with a very low investment. So starting with a few stations, starting with just collecting quality data, and start to scale to generative AI and start to scale to more advanced capabilities that we outlined over time once you have more understanding of where the biggest impact business-wise would be. And so ideally, the way that you're approaching that when you're thinking about investment versus return is this is where it makes sense to install this technology. For example, if it's cheaper and makes more sense for you to have a pick-to-light system because you already have that tech and you can connect it to something like Tulip, that's the way to go. If it makes more sense to, get an off-the-shelf camera and have a vision system because you are going to have to move your line around a lot and the station configuration is going to change more often, you don't want to have set bins. Maybe that makes the most sense for you, but the configurability and the fact that your internal team can help own it really reduces total cost of setting something like this up while setting you up to be able to use new technology capabilities as they come on the market.
Okay, next question. So anybody following generative AI in the press knows that hallucination is a concern with generative AI. Does Tulip's generative AI hallucinate?
It's a great question. It's definitely one of the top risks with a tool like this. We've taken a number of approaches to try to minimize this and really restrict the impact that this could have on your operations. Generally, though, in Tulip's product, these things are going to fail with an "I don't know" versus making up an answer. However, we still think that it's critical that these techniques are applied as an assist or a co-pilot to your operations. They're not going to help you go lights out. They're going to help your manufacturing engineers, your frontline operators, be more efficient and use it as a starting point for the next step that they're going to take.
The next question. How do you control what information an AI chatbot references?
Tulip has started our product development with sort of a first principle of only ever training and using information that is yours. We're never going to take one customer's information and train a chatbot or train a model that goes and benefits another customer. There's too much risk of leakage. Your IP is your IP. You don't want it benefiting anyone else. Within Tulip, you can go and restrict the information that you have access to. So say you want a chatbot around quality defects, you can go and train it just on your quality defect information. And it's going to just pull information from that table. And if you try to ask it something random that's not on that table, it'll stop and say, I don't know about that. I only know about this right here, to try to put guardrails and boundaries on it. Again, going back to that hallucination, I don't know is a way better answer than here's something that sounds correct but isn't based in reality.
So next question. How long does it take to build an app that uses generative AI?
So there's like a few different ways that you could use generative AI in Tulip, and they can kind of match your familiarity with the platform, but also what makes the most sense for you to apply to your business. For example, if you're an admin and you have a good understanding of the system and you want to do a more in-depth use case that uses translation and queries different defects, you might want to use AI triggers and do something that's in the platform. If you find that you need a lot of, paper work instructions and guidance and safety manuals, and that finding that material is really difficult on your shop floor, or you have, multiple shifts and people knowing and getting trained on that can be really difficult. Perhaps you want to start with a co-pilot where you're importing and training on that information so that people can ask and get answers quickly. Both of those are pretty, easy starting use cases, but it's really, what makes the most sense for your business to kind of invest the time. And once you have the data available, it's easy to start scaling or using those in different ways. So maybe you start with a PDF and then you move to multiple booklets after you kind of see the value from that.
What other types of new technology do you think will have a major impact on frontline operations in 2024?
It's a good question. I think that beyond the continued sort of deployment of LLMs and generative AI in these applications, we're continuing to see a lowered barrier of entry to some of these more traditional models. You no longer need to be a machine learning specialist in order to build an image classification model. There's a new class of tools emerging from the traditional providers like AWS and from other startups as well that continue to lower the barrier of entry there. And I think we'll start to see that be able to be deployed in a lot more niche use cases, where before, if you had to have a PhD to build a model like this, it means you got to get like $1 million of ROI for it to be worth it. But when you can build a model in 10 minutes and start classifying defective parts immediately, that really opens up a whole nother spectrum of opportunities that weren't possible before.
I think I can add, and Mason, keep me honest here, that we're still pretty early days when it comes to the best ways to use a lot of the technology that we have available. So the sophistication of the applications themselves, I expect to mature very rapidly. I mean, just looking at generative AI in January of this year versus now, and to Mason's point about Gartner moving us along the curve, there's a lot of maturity that's happening already. And I think the generative part we haven't seen fully emerge, then we can expect to to see emerge over the next 6 months and a year. So what that might look like is someone articulating the type of application that they need to solve, or the type of data model that they need, or what an analytic could look like, or more interesting combinations of different tools when it comes to data flows and the representation, like analytics of that, or how people interact interface-wise with content, like an application or Copilot, moving into, older HMIs or other types of automation. And I think we're just getting started with a lot of that technology, both at Tulip and across the ecosystem. Those are trends we're seeing emerging.
Yeah, agreed. And I think a lot of that is everything you just said, just to call it out or make it more specific, is use cases and applications of it. When you look at model performance over the last 2 years, you saw a step function change with GPT 3.5. You saw a step function change with GPT 4. And then you've seen incremental improvements, getting a little bit better at different types of media, getting better at certain subsets of questions. You haven't seen that next step function again, and it's not clear if or when that next step function will come. But where those models are today still has incredible additional value that is being realized and built into products. I mean, what was it, 2 weeks ago when Apple announced everything they were doing with it? More will be coming, more applications of these same techniques.
So next question, how does composability scale across multiple sites?
So I think what we find with, a lot of the companies that we work with is that they have dozens of sites, and across those dozens of sites, they may have shared processes or shared processes, and each site might have a different way of solving that process. And for some of them, when you look really deep into them, there is an optimal way to solve the process and kind of standardize that across the site that is the most efficient, and you can train people on that and kind of deploy that solution across every site. And in other scenarios, there's unique things that they make or unique challenges that they face that maybe requires either a different sub-tool or a different approach. And for a composable rollout across multiple sites, you can standardize core use cases and share them down while enabling localized problem solving and integrations and setup, and kind of create this process of continuous improvement where when you identify localized solutions that make sense to bring up and standardize, you can do that. And when it makes sense to have something that's really fit to the process and the people in that individual site, that's supported. So that kind of, how do you get the technology to fit to you versus like force standardization is enabled by a composable approach.
I also, to add on to that, I also think about it as a system of abstractions and layers. Right? When I'm using my computer here, I'm not thinking about what's going on at the low levels of my computer. That's built on top of this abstractions that are built to where I can now use the computer without having to know what a transistor does. The same thing is true on these composable approaches. When you have these modules that you can bring together, it doesn't matter how that module is implemented. It doesn't matter what system it talks to, who built it, whatever. You're given a better abstraction over that other system, and now you can compose that together into your own. So if you're going to go roll out a solution across multiple sites, maybe you can use that as an abstraction and don't have to worry about the implementation details. Maybe you need to swap that abstraction out and use something else that provides the same interface, but it's implemented differently because, hey, at this site, they use this ERP versus that ERP. It gives you better boundaries to scale something across a whole enterprise instead of having to go all the way down and know all of the details of every little bit.
Okay. That's the end of our Q&A session. I'd like to thank Madilynn Castillo, Mason Glidden, and our sponsor Tulip for today's presentation. On behalf of Industry Week, we hope you have a productive remainder of the day, and thank you very much for joining us today.
Thank you, everyone.
Thanks, everyone. Bye, folks.